Hello everyone, I welcome you all to this digital classroom for the subject control systems. Today we are going to solve few of the example problems related to time domain specification. You can take down this question. For a control system shown in the figure, find the value of K1 and K2 so that MP equal to 25% and TP is equal to 4 seconds. Assume unit step input. And the block diagram is shown here. You are given with maximum peak overshoot of 25%. Then we have TP as 4 seconds. And from the block diagram, you can simplify the block as K1 and 1 by S square are in series, two blocks in series. So you can take the product of both and you can represent G of S as K1 into 1 by S square. Therefore, I can write G1 of S as K1 by S square. And here we have a negative feedback with H of S is equal to 1 plus K2S. And you're given with maximum peak overshoot of 25% and peak time of 4 seconds. And input, we have to assume it as unit step input. And we have to find the value of K1 and K2. First, let us calculate the transfer function, which is given by G of S divided by 1 plus G of S into H of S. Let us substitute for G of S as K1 divided by S square and H of S as 1 plus K2S. Once after substituting for G of S and H of S in the transfer function formula, we get K1 by S square the whole divided by 1 plus K1 by S square into 1 plus K2S. Further simplification, we get the closed loop transfer function as K1 divided by S square plus K1 K2S plus K1. Now let us compare the denominator of the characteristic equation with the standard characteristic equation, which is given by S square plus 2 zeta omega n into S plus omega n square. From this, it is very clear that omega n square is equal to K1 and 2 zeta omega n. If you compare the coefficient of S with respect to the denominator of the transfer function, 2 zeta omega n will be equal to K1, K2. Therefore, once after comparing with the standard form, omega n square is equal to K1. Therefore, omega n will be equal to square root of K1, as well as 2 zeta omega n will be equal to K1, K2. Hence, I can write zeta is equal to 1 divided by 2 into, let us substitute for omega n as square root of K1. Hence, I get 1 by 2 into square root of K1 into K2. We know the formula for maximum peak overshoot MP, which is given by e to the power of minus pi zeta divided by square root of 1 minus zeta square into 100. If you wanted to calculate MP in percentage, you have to multiply it by 100. In the question, MP is given as 25%. Therefore, 25 equal to e to the power of minus pi zeta divided by square root of 1 minus zeta square into 100. 20 divided by 100, I get 0.25, which is equal to e to the power of minus pi zeta divided by square root of 1 minus zeta square. As we have e to the power of minus pi zeta, let us take logarithm on both sides. So we get the expression as ln of 0.25, which is equal to minus pi zeta divided by square root of 1 minus zeta square. ln of 0.25, we get minus 1.3862, which will be equal to minus pi zeta divided by square root of 1 minus zeta square. So for the simplification, I can square on both sides. Therefore, I get the expression as 1.9218 into 1 minus zeta square, which will be equal to pi square into zeta square. Further simplification, I get zeta square is equal to 0.1629. Therefore, zeta will be equal to 0.4037. Once after obtaining the value of zeta, now in the given question, the peak time Tp is given as 4 seconds. We know the formula for Tp, which is given by pi divided by omega d. And we know that omega d equal to omega n into square root of 1 minus zeta square. So let us substitute for omega d in this expression. I can write it as pi by omega n into square root of 1 minus zeta square, which is equal to 4, which is given in the question. As we know that zeta is equal to 0.4037, let me substitute for zeta here in this expression. So for the simplification, I get pi by omega n into square root of 1 minus 0.4037 the whole square, which is equal to 4. Cross multiplying and simplifying further, I can obtain the natural frequency omega n is equal to 0.8584 radian per second. Once after obtaining zeta and omega n, in the beginning we have compared with the standard characteristic equation and we have obtained omega n is equal to square root of k1. So let me substitute for omega here in this expression. Therefore, I can obtain the value of k1. So once after substituting for omega n as 0.8584, I get k1 is equal to omega n square, which will be equal to 0.8584 the whole square, which is nothing but 0.7369. We have obtained the value of k1. Similarly, we know that zeta is equal to 1 by 2 into square root of k1 into k2. This is the expression which we have compared with the standard characteristic equation and we have obtained this in the beginning. Now we know that zeta is equal to 0.4037. So let us substitute for zeta here in this expression and we have obtained the value of k1 as 0.7369 just now. Let us substitute for k1 in this expression. So we can obtain the value of k2. For the simplification, we obtain the value of k2 as 0.9403. So from the given expression, with a block diagram, you are given with g of s and h of s. And in addition to that, you have given with an information of maximum peak overshoot and Tp. The first step is to calculate the closed loop transfer function. Once after calculating the closed loop transfer function, we compared the denominator of the closed loop transfer function with the standard characteristic equation s square plus 2 zeta omega n s into omega n square. Then we represented omega n and zeta, and making use of MP and TP, we have obtained the value of omega n and zeta. Once after obtaining for omega n and zeta, by substituting in the comparison equation, we have obtained for K1 and K2. This is the same type of problem which has been taken from model question paper, which has been released by VTU recently. From model question paper 1, 6b, we have the same question. For servo mechanism system, G of s is equal to K1 divided by S square and H of s is equal to 1 plus K2 into S. Determine the value of K1, K2 so that the peak overshoot is 0.25 and the peak time is 2 seconds for a unit step input. The problem which we solved right now, the only small change is that TP we solved with 4 seconds, in which in the model question paper they have given with TP as 2 seconds. Rest of all remains the same. You have been given with a block diagram, whereas here they have given the expression of G of s and H of s in the similar fashion which I solved right now. So students, try to solve this problem and you can post it in the Google Drive. In the next lecture, let us solve few more example problems related to module 3 from the model question paper. Thank you.